Good morning, everybody, and welcome. Thank you for joining us. My name is Joshua Karasak. I'm a winemaking specialist with Enartis USA. And the topic we're going to be discussing today is rapid clarification, tips and tools for clarifying juice and wine during harvest. So if you've never been to one of our webinars before or are not familiar with the format of our webinars, I'll just quickly go over an overview of how the webinars work. So you're looking at our webinar platform right now. On the right-hand side, there is a chat box. There's a little arrow on the left-hand side of that chat box. You can use that to open and close the chat box if you like. We generally use that if you are getting distracted by activity in the chat box and you want to just close it off, you can do that. In general, we ask that you don't use the chat box for questions until we get to the very end of the presentation. The presentation is about 40 minutes long, and then afterwards we'll do about a 20-minute question and answer session. During the question and answer session, we will address any questions that you have from the presentation itself. During the presentation, we would recommend that you have a pen and paper nearby that you can just sort of jot down any questions that you get during the presentation itself. Other things, we are recording this session, so if you have some issues with your connection or you're just not able to stay for the full presentation, you will be able to access this recording afterwards. We are recording the whole session, the question and answer included. So if you have any sensitive information that you don't want to share online, we recommend saving that information and addressing it at another time, not in this webinar. So we'll go ahead and get started. As a general overview, I'm going to be talking about finding and clarification first, the differences between flotation and static settling. We'll address Stokes' law and how we can look at Stokes' law and understand it, how it affects clarification. We will talk about decreasing juice viscosity, an important component of Stokes' law. We'll talk about filterability improvement, colloids, and increasing flocculation efficiency. So what are the objectives of juice finding? Why are we finding juices? Most of what I'll talk about today is clarification improvement. So we add finding agents to juices to make clarification more effective. We add it for removal of bitter compounds, removal of astringency, more oxidative stability, improving browning potential essentially of those subsequent wines made from those juices, remediation of off flavors, stabilization of proteins. So many times winemakers will add bentonite to juices in order to reduce the total amount of bentonite they need to add to a subsequent wine. Also, there are for many wines, there are quality improvements by adding the bentonite to the juice rather than to the wine. Removal of bacteria and wild yeast is a sort of a newer juice finding objective, but in general, winemakers who are using products like chitosan find that removing the bacteria and wild yeast from juices tends to improve fermentation, also clarification as well. So there's many different reasons why we're adding finding agents to juices and why we're finding juice, but the main one we'll talk about today is clarification improvement. So why do we want to clarify juices? There's many different reasons for why we want to decrease the turbidity of a rosé or white juice. One reason is avoiding reduction. So elemental sulfur that comes in with grapes. Grapes are sprayed with elemental sulfur or wettable sulfur to reduce powdery mildew activity. And sometimes that residual sulfur makes its way into the juice itself. And what's been found through work that was done by Kwasniewski and Gavin Sachs, Wilcox, and at Cornell was basically looking at the residual levels of sulfur and also the effects of solids on the residual levels of sulfur. So basically what they found is the more clarified a juice is, the less residual sulfur is present in the juice. And residual sulfur in juice during fermentation is not good because yeast can basically form reductive compounds when there's residual sulfur present. So it's very important that you clarify a juice that has had sulfur sprays because that will remove the potential for H2S formation and fermentation. So avoiding reduction is one reason. Esterase activity in solids, so higher your solids levels are in the juice, the more esterase activity you have. Esters are formed by yeast during fermentation. They are beneficial aromas in many cases for white wines. And so esterase activity basically breaks down those esters, and so you have less aromas. So decreasing your solids levels can lead to less esters. Some wine styles might benefit from that activity. For instance, more mineral wines tend to benefit from less esters. But in general, that is one reason why we'd want to decrease the turbidity. Polyphenol oxidase activity is higher in solids, so the less solids you have in the juice, the less PPO activity you will have. More solids have been correlated to herbaceous alcohols and aldehydes, so more herbaceous compounds when you have higher solids. And it also results in more delicate and fruity wines. So these are just general sort of reasons why winemakers would want to decrease the turbidity. And so you can see it stylistically, there's a lot of things that happen when you decrease the solids levels. But these are just some of the reasons why we'd want to clarify our wines or our juices. So let's talk about flotation versus static clarification. So flotation is a newer method of clarification. Static clarification is sort of the classic way to clarify wines. So if we were to look at, let's say, a turbid juice that's subjected to static clarification, generally speaking, what you do is you turn on a chiller and you let a juice sit there and let gravity basically take all of the solids in the juice down to the bottom of the tank, forming a Lees cake. That's static clarification. Most winemakers are using this in the US for clarifying juices. Flotation is a newer technology. It's been used in the US for a while now by some wineries. It's used very commonly in the Southern Hemisphere in Australia and New Zealand. And basically the premise of flotation is you have either a pump or a continuous process that injects micronized nitrogen bubbles into a juice, basically pushing all of the solids in the juice up to the top, forming a Lees cake on the top, aka fleas. And that fleas cake essentially remains on the top. You rack the clear juice underneath the fleas, and then you have a clear juice. So it's sort of the opposite of static clarification. It works pretty well in terms of the efficiency and speed of which you can clarify a juice. So that's why a lot of winemakers use it. It is a more technical process because you have to understand how to use the machinery. Also, you have to understand how to prepare juices for flotation. We'll talk a little bit about that today. And I'll also provide you with some materials that will give you more information on flotation itself. Static clarification, we have a longer period of time that's required for the clarification itself. You may remove some tartrates because of the cold temperatures over time. But in general, it's a tried and true method for getting rid of the solids in the tank. And it requires very little labor involved or anything like that. It basically, you just turn on the tank chiller and let it settle for a day or two, just depending on how big the tank is and how much lees you have. So that's the difference between flotation and static clarification. So keeping these things in mind, we can talk about Stokes' law. So Stokes' law is essentially a law that says that the speed of a particle, or in this case a floccule, I'll just quickly define what a floccule is. A floccule is essentially an agglomerate of particles. So if you have a couple of different particles that get stuck together, that forms a floccule. When we're fining a juice, we're adding a fining agent to fine out something. When the fining agent interacts with that thing we're trying to remove, it forms a floccule, and that's essentially part of the process of fining. So the speed at which that floccule moves through a juice or clarifies the clarification speed of a juice is dependent on the density difference between the particle and the liquid. So the more dense the floccule or the particle is compared to the liquid, the more quickly it will move through the liquid. The lower the viscosity of the juice, the quicker that floccule is going to move. and the larger the diameter of the particulate or floccule, the faster it will move to the liquid. So basically, decreasing juice viscosity, increasing diameter, and increasing density of the particulates increases the speed at which the floccules move through the juice. So these are things that we can keep in mind when we're trying to think about how we can clarify juices more effectively. So when we're talking about clarification of Stokes' law, we can talk about those three things separately. How do we improve the effectiveness of our clarification? We do it by decreasing juice viscosity, increasing particle or floccule density, and increasing particle or floccule diameter. So first we'll talk about decreasing juice viscosity. One main component in juice that has a dramatic effect on viscosity is pectin. Pectin is present in many different plants, fruits, vegetables. Basically it's like cement or glue for plant cell wall structures. It's a polysaccharide, and it helps form basically a cellular network between cellulose microfibers, hemicellulose, proteins, and that basically makes up the cell wall structure. Pectin is broken down as fruit ripens naturally within the fruit. So the less ripe the fruit is, the more pectin you have in it. If you've ever made, let's say, a jam or a jelly before, you may have had to add pectin in order to make a more solidified jam or jelly. And so that's the effect that pectin has in juice as well. It increases the viscosity and it makes it thicker essentially. Pectin is not all the same though. Depending on the fruit you're looking at, the variety, you have different kinds of pectin and different structures within pectin inside of different material. So pectin, we can basically break down pectin with enzymes, and so different kinds of enzymes can affect different parts of pectin structure. I'm not going to go over all the different structures of pectin because I don't have enough time to do that, but let's just say that there's different structures within pectin, and there's different enzymatic activities that can break up those different structures. So if you really want to break down pectin quickly, you want to use a pectin preparation that is able to cut this pectin at different points. So you have pectin that can break it at different parts, different chains, different branches on the pectin molecules, and that leads to a more effective breakdown of the pectin itself, and therefore a decrease in viscosity and also a easier to clarify juice. So now I'll introduce you to three different enzymes that Enartis offers as pectinases. Our Zyme RS is going to be the fastest and most efficient broad-range pectinase in our range. It works very well on difficult to clarify juices. It works very quickly. In a matter of a couple hours, you can completely depectinize a juice with this enzyme. And that's because it has a broad range of pectinase activities, breaking up the different parts of pectin and making it degrade very easily. The Enartis Zyme Quick is a pectin preparation specific for flotation. So if you're doing flotation, this enzymatic preparation was made specifically for that. It works very quickly on pectin and cuts it in a specific way that is beneficial for flotation. Another new enzyme preparation that we're very excited about is the Enartis Zyme Easy Filter. This enzyme was originally developed to make filtration on wines easier because it has pectinase and glucanase activity. I'll talk more about glucans in a couple of minutes, but essentially its pectinase activity is also very broad ranged, and so it works very well to quickly depectinize juices and also works in wines as well. So between these three enzymes, you can find one enzyme that essentially can help you with depectinizing your juice, making the juice less viscous and easier to clarify. Here, what we did is we looked at a time-lapse video of the same juice. One was not treated with enzyme, one was treated with Zyme RS, and one was treated with Zyme Easy Filter. So over the course of 2.5 hours, we basically did a time-lapse video, and you can see the effect of the clarification on the RS and the easy filter and the control over the course of 2.5 hours. You can see that most of the juice is completely clarified and depectinized at that time. And so this is the impact of pectinase in terms of clarification. So very impressive results in terms of enzyme activity. So I just want to quickly talk about glucans too and their effect on clarification and filterability. Glucans are typically found in fruit that is affected by botrytis. And so glucans are produced by botrytis cinerea, and they're exopolysaccharides that are excreted, and they increase the juice viscosity as well as decrease the clarification and filterability of those juices in subsequent wines. So if we are thinking about a particular vineyard that has some botrytis pressure, you might want to think about using an enzyme that has not only pectinase activity, but also has glucanase activity, such as the easy filter that I mentioned before. If you look over on the right, you can see the effects of glucans on white wine. So this was some early work done on looking at glucans and the effect of glucans on wine filterability. And you can see that so we have varying degrees of glucans added to this wine, and they looked at the volume of filtered wine over time. And you can see that the higher the increase of glucans, the greater the difficulty with filterability. So just something to keep in mind. If you have botrytis affected fruit, you might want to address the glucans and the juice because you will most likely have difficulty filtering those wines later on in the wine's life. And I can't tell you how many winemakers have come to us after they've gotten to the point where they're starting to filter their wines and they can't filter their wines. And it's a real challenge because this enzyme takes a little bit longer to work in wine because of the alcohol. But in juice, it works very, very quickly. So if you have a botrytis affected lot and you treat it in the juice, you can have a wine that filters beautifully. But if you don't treat the glucan issue in the wine and you wait until the very end of the process and you start filtering it, you're going to basically have to delay your bottling potentially by weeks to be able to degrade those glucans. So just something to keep in mind. Proactive approaches with botrytis are definitely recommended. Looking at the easy filter, this is just a little bit of data to show you one trial that we did recently, looking at the impact of the easy filter on a Pinot Noir. And essentially what we saw was a 25% decrease in total time required for filtration, which is a pretty significant impact in terms of labor and in terms of time required for filtration. And so that's what the easy filter does, is it basically improves the filterability. But also it has other benefits too. The glucanase activity, we know, improves the release of mannoproteins from yeast. It improves protein stability when it's used in the juice. In fact, we've seen some juices that come out of fermentation that were treated with the easy filter with significantly less bentonite requirements. And so it's a pretty awesome tool for winemakers in terms of ease of use and improving their process. So now we're going to move past the juice viscosity and talk about increasing particle or floccule diameter, as well as increase of particle or floccule density. So some of the basics of juice finding. So the desired outcome is to remove something from the juice by addition of charged compounds. So we're adding something that's charged to the juice. That charged compound is going to neutralize something that's in the juice that we want to remove. They form floccules, they sediment, and then we rack off of that, that sedimented particulates. So finding and clarification of juice. Now we're going to talk about what colloids are, a colloidal system. So juice is a colloidal system, and what a colloidal system is essentially when you have an insoluble fraction which is dispersed and insoluble and suspended inside of another dispersing or continuous substance. So a grape juice itself is a colloidal system. You have an insoluble fraction, which is something like proteins, pectin, polysaccharides. It's some charged compound that's insoluble and very small, and it's basically dispersed in a liquid. It's a little bit more on colloids, so they're either charged positive or negative. There's usually dispersion forces between those insoluble fractions that keep them in suspension. They're too small to fall out of suspension, so they just stay there, charged and kind of in suspension. And so that's more or less how colloids work. A little bit more on colloids. So when we have a loss of charge or dispersion forces, that's when we start to form agglomerates. So when we add a fining agent that is opposite charge of that colloid that's already present in the juice, they interact, it forms a net neutral agglomerate or net neutral particle. And then hydrophobic interactions tend to push those particles together and they form these agglomerates or these particulates, and then they settle or float out of suspension depending on what you're doing. So some examples of juice colloids are polysaccharides such as pectin, cellulose, hemicellulose, glucans, proteins, usually grape-derived, polyphenols, either monomeric or polymeric, tartrates, colored matter. So there's a lot of different charged compounds that are insoluble, very small, present in grape juice that we will typically need to fine out in order to clarify a juice. So here are some fining agents to increase flocculation. Some of the options are animal-based proteins such as gelatin, casein, isinglass. These are classically used in winemaking as enological tools for increasing clarification. Although lately, with more consumers looking for vegan alternatives to animal-based products, there's been more demand for vegan fining agents for that reason, and having wines that are vegan friendly. So basically, there are now options available to winemakers in terms of vegan fining agents. Very good options, in fact. The pea protein is a fining agent that's used on many different countries in the wine industries in many different countries. The United States doesn't currently have it listed on the TTB as an approved fining agent. It is a FDA GRAS approved product, so it's a safe, food-friendly product to use. It's just not listed by the TTB yet. So we're encouraging winemakers to request the use of pea protein to the TTB. I have a document I'm going to share with you all at the end of this presentation. It's a very simple to fill out document that basically requests the use of the pea protein to the TTB. We'll ask that individuals who are interested in using pea protein as an alternative vegan fining agent, that they request to use this fining agent from the TTB, and that will speed up the process of the TTB allowing the industry to use it, because the more demand that we show for the fining agent, the more the TTB will respond to that demand. So currently we have several wineries that have just applied for the use of the pea protein that were all approved, so they can use it this year experimentally in their wine, and that wine can be sold. So if you want to use it this year, you still can. You just have to submit it to the TTB. They may or may not respond before harvest, so the sooner you get the letter out, the more likely you are to be able to use it. Potato protein is another fining agent that's a vegan protein. Both potato protein and pea protein have similar effects to casein and gelatin in terms of their ability to remove some oxidative precursors as well as bitterness. Chitosan is a newer vegan fining coadjunct that we are very excited about in terms of its ability to increase the effectiveness of other fining agents and also to do fining itself. So I'll talk more about chitosan in a couple of minutes. Silicosol is a mineral that's basically highly charged that is added as a co-fining agent to essentially improve the effectiveness of flocculation and formation of floccules. Bentonite is sometimes used to increase flocculation because it has its own charge as well. So all of these fining agents are things that we're adding in order to increase flocculation and increase the density and diameter of the floccules we make, making clarification more efficient. So what are the options in terms of animal-based proteins? So gelatins, not all gelatins are created the same, and so there's different options in terms of the gelatins that you use for different applications. These are the gelatins that we offer that are useful for clarification of juices. The hydrochlor 30 is one that is a average amount of hydrolyzation. What that means is that it works well in many different kinds of juices for clarification, also for removal of astringency. So the hydrochlor 30 is if you're looking for one gelatin to use in many different kinds of juices, that's a good one to go with. The Polyphenols S is a very effective finding agent in terms of its ability to clarify. It is in a granulated form, so it's a little bit difficult because it needs to be kept warm. So it's soluble in warm water. So wineries need to be able to keep it warm before application. So it's a little bit tricky to use, and if you're able to handle it properly, it works great. It works really, really well. It's super effective, but it's just in a different form. It's not a liquid form, so it needs some preparation first. But it works really, really well in flotation as well. Clargel is something we recommend for high quality musts. It's medium hydrolysis, similar to the hydrochlor 30, and it's also in a liquid form. So these three options are all your sort of classic gelatin that you can use for clarification. There are vegan alternatives, as I mentioned before. We have pea protein as the Plantus AF, so it's good at oxidative removal, increases flocculation, and decreases bitterness. You do need to request at this point from the TTB to use it, but it's still you can still use it. You just have to request it first. Plantus AFP, this is potato protein finding agent. Similar kind of activity to the pea protein. The pea protein is a little bit more effective than the potato protein, which is one reason why it would be good for the US to start using it, is because it's one of the best vegan finding agents out there, and we still can't use it. But the potato-based protein is also very good as well. So looking at improving finding efficiency with chitosan. So chitosan, kind of similar concept to gelatin. Not all chitosans are made the same. In general, our pre-activated chitosan can be processed in such a way to change its activity. So typically chitosan is used for antimicrobial activity, and with low hydrolysis level, it has high antimicrobial effect, but less clarification effect. With a little bit more hydrolysis, you lose some of the antimicrobial effect, and you begin to increase the clarification effect. And then with a high degree of hydrolysis, you have no antimicrobial effect, but you have a very high finding effect. So there's different forms of chitosan. There's pre-activated and non-pre-activated. We have pre-activated chitosan that undergoes a lot of hydrolysis, which makes it a very good finding agent because it's very densely charged and is able to find quite efficiently. And used in combination with other proteins, such as potato or pea protein, it dramatically increases the ability of that protein to form floccules and to clarify. So it enhances the activity of other finding agents by increasing the amount of charge on those proteins. So its effect is dramatic in terms of improving finding effects. A new exciting blend that has just come out this last year is a blend of potato protein and pre-activated chitosan. So it improves oxidative stability, increases clarification, improves density of sediment of the fleas or the lees in classic static clarification, and also removes bitterness. And it is allergen-free, organic compliant, and vegan. So if we are to look at, over on the right here is an example of a flotation trial where we floated the same juice, one treated with Plantus PQ before flotation, and one control which didn't undergo flotation, or I'm sorry, didn't have any treatment with Plantus PQ. And I want to point out not only the volume of the actual liquid juice, but also the density of the fleece cap formed at the top. You can see that the Plantis PQ forms a much more dense and compact fleece cake, which means that you have more efficient fining and more efficient clarification happening. It's kind of hard to see in this picture the difference between the turbidity, but there was a dramatic difference in terms of the clarification effect of the Plantis PQ, and also dealing with a juice that has a less dense fleas on top can be quite difficult from a processing standpoint. So the more dense the fleece cake is on top, the easier it is to handle and to filter. If you're planning on filtering the lees afterwards to get more volume out of it. But also the juice yield that you get from this treatment is significant. Other impacts with using the Plantis PQ, the oxidative stability of wines treated with Plantis PQ is dramatic. So here is a wine that we treated with one without and one with treatment of Plantis PQ. We saturated that wine with oxygen, and then we set that wine aside for 4 weeks at room temperature, and then measured the change in absorbance at 420 from the beginning until the end after of the treatment. And you can see that the increase in browning or absorbance at 420 between the control and the Plantis PQ is dramatic. So when we measure the absorbance at 420, we're measuring the amount of yellow hue or the amount of browning that's occurring. And so you can see the control has a dramatic increase in the absorbance at 4 weeks, and where the Plantis PQ has a very small increase in the browning. So wines and juices treated with Plantis PQ have less susceptibility to browning and therefore oxidation. Other beneficial impacts when we're using the Plantis PQ, we see impacts from an aromatic standpoint in terms of improved aroma intensity, cleanliness, aroma complexity, volume, increase in acidity, increase in persistence. So in general, significant sensory benefits as well. So in conclusion, first, clarification of white and rosé juices does have a dramatic effect on the style and quality of subsequent wines that are made from those juices. So that's why we're clarifying wines to begin with, or clarifying juices to begin with. We can dramatically decrease the time for clarification by using broad spectrum pectic enzyme like Enzyme RS, Enzyme Quick, Enzyme Easy Filter. Winemakers can use fining agents like Hydroclar 30, Plovoclar S, and Clargel to increase the flocculation and thereby settling or flotation efficiency. And then new innovative vegan fining agents like Plantis PQ can be substituted for gelatin to improve juice clarification, oxidative stability, and aromatic qualities. So I just want to thank you all for joining us for the presentation today. I know we went through a lot of information in the course of this presentation, and so I thank you for joining us for that.